Welcome to the project demonstration of IoT transmission line fault monitoring and controlling system. So here we are going to identify the faults of voltage increasing and current increasing sections, and that will be identified by the Raspberry Pi 0W through the comparator, because Raspberry Pi 0W doesn't consist of any inbuilt ADC. So that's why we are going to converting the analog voltage into digital voltage with help of this comparator, as we set the reference voltage from these two potentiometers for the voltage and the current. So the transmission lines is going to provide the input of 230 volts input from this power cable, and once the 230 volts input is given to the 230 volts to the transformer, so it will step down the 230 volts to 12 volts of AC, and after this rectification of 4 diodes as a bridge rectifier, we will get the pulsating 12 volts DC, and after this capacitor we will get the 12 volts pure DC, and by that, using this 705 regulator, we will get the 5 volts constant regulated power supply. That was the main power source input to the our analog to digital converter circuit as well as to the relay. And the load is going to be the controlling load is bulb, we are representing that, and that will be controlled through the electromagnetic relay, which is 5 volt operated. Coming to these connections, so we have interfaced the pin number 2 to relay, and 3 and 4 respectively for voltage and current, and 11, 9, 10 and 22, 17, 27 is for the LCD module. So before switching on this kit, we need to enable the hotspot in your phone. Just go to the hotspot settings of your phone, right, and go to the hotspot settings and change the hotspot name to project 4716, all are capital, all are small letters without any space, and password 129. And after the enabling the hotspot, enable the data also, this is very important. And after that, give the main power source to this adapter as well as our transmission lines cable socket, right. So when we switch on this kit, so it will take some time initialization till that the relay will be on position only, and once the booting was successfully done, the welcome message will be displayed on our LCD screen, and after that it will check with the so-called voltage and current sensors data, and then the relay will get switched off or on. So it will take maximum of 20 to 30 seconds, right. Initially it will be off, and then it will check the sensors data, and now the status is normal. So for every 12 to 15 seconds of duration, Raspberry Pi 0W will send the so-called status of our voltage, current and relay status to the ThinkSpeak. So this is the ThinkSpeak. Just log into ThinkSpeak from the given credentials. Now we can see the voltage level is 0 and the current is 0. Now its previous status is high and low, and now the relay is 1, nothing but it's in on condition. So if you want to download this data, just go to channel settings. Right, so now for the channel settings, right, and in that download, to download that data import and export, and now download the data. It will be downloaded in Excel sheet, the CSV format, it's comma separated values, and we can open that. So from here we can know the right. So here, so the data is stored in terms of like date and time and number of entries, how many entries are happened. We can see the entry ID. Field 1 is a voltage and current and relay status. So we can see these status whenever the error occurred, so then the relay will be in off condition only. So and after downloading this data, so now we can clear that by going to the channel settings, and now do only clear channel, right. And now I'm clearing the channel, so it will prompt us clear channel was done, and now go to the private view. There we can see the data of the sensors will be uploaded now for every 12 seconds of duration, right. We can see the now new data got uploaded. So now the voltage is no fault, current is no fault, that's why the relay is on condition. So now let us make the error for just increasing the I. Then there will be 2 indications on the LCD as well as the LED indication on our comparator board, and after 15 seconds of duration, maximum 15 seconds of duration, we can get the new data will be uploaded to the ThinkSpeak, right. So now I got the status of current is 1, nothing but the fault occurred, the relay is 0. So the relay got switched off, and now we make it as normal, and we'll make the voltage varying. Again voltage fault displayed on the LCD screen, and now here same. Now the current will falls down to 0 and the voltage is for 1. So in this manner we can get controlling and monitoring of transmission line faults in terms of voltage and current, like as shown in this video. Right, so make everything is normal. Right, so as shown in this video, we can download the so-called data. Right, you got the new data, so everything is normal now. Right, normal. Thank you.